In this video, you're going to learn how to identify and name type 3 compounds. Unlike the type 1 and type 2 compounds, type 3 compounds are molecular compounds. And molecular compounds are held together by covalent bonds. Covalent bonds just means that they share electrons. And let's get back to this molecular. What does that mean? Molecular just means nonmetals with other nonmetals. So all of these type 3 compounds are just going to have nonmetals in them and shouldn't ever have a metal in them. And we're going to focus in on just binary type 3 compounds. And binary just means that there are 2 elements in the compound. So that you can't be more than 2 elements in the compound. Once you identify some compound as a type 3 compound, what you're going to notice about all type 3 compounds is that they always have a prefix in them. And the prefixes that you're going to need to know or memorize are the prefixes from 1 to 10. Mono means 1, di means 2, tri is 3. This one is a little bit confusing for people. Tetra is 4. Penta denotes 5. Hexa 6. Hepta 7. Octa 8, nona is 9, and finally deca is 10. These prefixes actually keep on going up, but in this class all you need to know is 1 through 10, mono through deca. When looking at a periodic table, you can tell the nonmetals from the metals because everything to the right of the staircase is a nonmetal. So all of those guys that I've outlined there are nonmetals. So in these type 3 compounds, you're only going to be seeing those elements. I've given you the rules there for naming type 3 compounds. The first rule is that the first nonmetal is always named first, and prefixes are only added for the first element other than mono. So if there's one of the first element, you're not going to write mono. The second rule is that the second element is named with "-ide". So you're always going to have the suffix "-ide" on the second element. So everything is going to sound like something something "-ide". And the third rule is that you want to make sure and add a prefix to the second nonmetal to express the number of that nonmetal. It's only in these type 3 compounds that you see prefixes. So you know automatically, given a name, if you have a type 3 compound, if you see a prefix in there. Now let's look at the practice set. The first one is CO2, which you should have seen in biology. We know that this is a type 3 compound because carbon and oxygen are both nonmetals. So this is going to be called carbon something oxide. So the second element has "-ide" on the end of it. We only have one carbon, which means we're not going to write mono. You never write mono in front of the first element. And the second element we have 2 of, and our prefix is di. So that is carbon dioxide. Okay, the next one is S2O3. Again, we know this is a type 3 compound because sulfur and oxygen are both nonmetals. So this is going to be sulfur something oxide. There's 2 sulfurs this time, so we need to go ahead and put a prefix there. The prefix for 2 is di, so that's disulfur. and there's 3 oxygens. The prefix for 3 is tri. So this compound is disulfur trioxide. In the next one we have what we commonly call water, but it does have a technical name. This is going to be hydrogen something oxide. Now let's take care of the prefixes. There's 2 hydrogens, so that's going to be dihydrogen. There's only 1 oxygen, so that's going to be mon. And the reason I'm using mon instead of mono for the oxide is because you never want 2 oxygens in a row. And you'll notice it sounds really weird to say monoxide. So that's why it's just monoxide. So even though the common name for this is water, the technical name is dihydrogen monoxide. Alright, let's go in the practice set to some names and figure out what the formula is. Carbon monoxide. Carbon obviously means it has a carbon, and because there's no prefix, that means just 1 carbon. And we know that there's also oxygen in here because of the oxide, and the prefix mon means 1, so we just have 1 oxygen. So carbon monoxide is just CO. Okay, let's take a look at the next one, dinitrogen trioxide. Dinitrogen trioxide. So we know because of the nitrogen that there's going to be nitrogen in this first, and the oxide tells us there's going to be O. This time we have prefixes on both of these, so we're going to need to take into account the number of each element. Dinitrogen means 2 nitrogens, trioxide means 3 oxygens. So dinitrogen trioxide is N2O3. The thing that we are not going to do with the type 3 compounds like we did with type 1 and 2 is divide the subscripts by the greatest common factor. So let's take a look at an example of this. Dinitrogen dioxide. Dinitrogen dioxide is N2O2. And normally if we had a type 1 or type 2 compound, we would actually divide both of these subscripts by 2. But because this is a type 3 compound, we're not going to divide the subscripts by anything, which means dinitrogen dioxide is just N2O2. It's not NO. NO would be nitrogen monoxide. The biggest mistake made with type 3 compounds is for people to try to split the compound down the middle. For example, let's say we had nitrogen dioxide. They would split the compound down the middle, and they would write ions for each of these. They would say N-3, and they would say oxide O-2, and then they would cross these numbers over. Be sure if you have 2 nonmetals that you're never crossing anything over. So type 3 compounds don't cross anything over. The number, the prefix in front tells you how many of that element there are. If you want to, you can pause the video here and try the problems down below on your own while I go through the answers. I've asked you to name the first one CCl4. This is going to be carbon something chloride. There's only 1 carbon, so there's going to be no prefix that goes in front. There's 4 chlorines, so that's going to be tetra. So this compound is carbon tetrachloride. The next one is CO3, so this is going to be carbon something oxide. There's only 1 carbon, so there's no prefix in the front, but there are 3 oxygens, so I need to put tri as a prefix there. So this is carbon trioxide. The next one is N2O4, so that we know this is going to be nitrogen something oxide. This time we have more than 1 of the first element, so this is going to be dinitrogen, and we have 4 of the second element, so that's TETR, tetroxide. If you put tetraoxide, that sounds kind of weird, so that's why we just call it tetroxide. So that's dinitrogen tetroxide, not dinitrogen tetraoxide. Alright, let's go from the formulas to the names to the formulas. The first one we have there is phosphorus pentoxide. So phosphorus is P, and then we can see oxide here, so there's going to be O. There is no prefix here, so that means one phosphorus. There is a prefix pent on oxide, so that's 5 oxygens. So phosphorus pentoxide is PO5. The next one is diphosphorus monoiodide. Diphosphorus iodide. Okay, so this is going to have phosphorus in it and iodine. It looks like based on the prefix here there's going to be 2 phosphoruses, and based on the prefix for the iodide there's only going to be 1 iodide. So diphosphorus monoiodide is right here. The last one on your sheet is chlorine diiodide. So chlorine diiodide. So that has chlorine in it and iodine. And there's no prefix in front of chlorine, so that means 1 chlorine. There is, however, a prefix in front of iodine, and that's di, so that's going to be 2 iodides. So chlorine diiodide is Cli2. When you come to class, you should be able to identify a compound as a type 3 binary compound. Binary meaning just 2 elements in it. And you should be able to name those compounds. You should start to be able to name type 3 compounds when you get to class.